Hello and welcome to my video lesson 6.5 on the binomial theorem. So to understand binomial theorem, I'm just going to remind you that you for sure need to first understand the idea of Pascal's triangle. So I'm just going to really quickly show it in case you haven't seen it before. But it's this triangle here, and it's coming based off of the combination form of the triangle. And so these combinations line up with these numbers. So if I pick this one, it should be this one should be this one, etc. So we can actually solve any value for a combination using Pascal's triangle if we wanted to. But more importantly, we can find binomial theorem answers using combinations and using Pascal's triangle. So go watch that video if you haven't. One of the things I just want to point out really quickly is that these are symmetrical with each other. 1, 6, 15, 15, 6, 1. 1, 4, 6, I guess, and then 6, 4, 1. So even if they have an odd number, it's still kind of symmetrical if you cut that middle number in half. Okay. So what does it mean for binomial expansion? Well, it's the same thing as the triangle. So this has a 1, a 1, a 1, a 1, a 1, a 1, just like all these guys. And over here, 1, 1, 1, 1, 1. So it matches with what we saw before. 2, 3, 4, 5, 6. 2, 3, 4, 5. Now we don't go down to 6 here, but you get the idea. 6, 10, 15. 6, 10. That's it, right? So you can see, hopefully, how these numbers are kind of matching with binomial theorem. And so binomial theorem uses this idea of Pascal's triangle and uses this idea of x plus y to the exponent. Normally, I'll say like n or whatever, and then it expands into whatever it expands into. Okay? And so what we can do is we can use that idea and this formula here. The computer doesn't like me typing this into an equation, so it was a little bit upset there, but you can kind of see the right idea anyway. But this is a picture of it, so you kind of get the idea. Anyways, this formula is in your formula sheet, and so we can solve for any form, any term using this formula. And so yeah, we could expand out a simple expression pretty easily. So if we had something like, let's do a simple one first. So if we had something as simple as 3x plus 2y to the exponent 4, what we can do is just look at the one that matches, just keeping in mind that the x and y here are different than the x and y here, right? The x is now 3x. So when I write this down, instead of copying it down exactly as it was, I'm going to write it in as 3x to the 4 plus 4 times 3x cubed times y, but it's not y, it's 2y. Plus 6 times x, which is 3x squared, times 2y squared, plus 4, and you can see again it's symmetrical, so we already know it's going to be a 4, but this time it's going to be 3x and then 2y cubed plus 1 times, I guess I'll just write it as 2y to the 4. So if we wanted to expand this out completely, you certainly could. This would be the expression. On a diploma, you have a lot of time, so it might be worth actually expanding the entire thing out so that you don't make a mistake. But I'll show you some simpler, or like how to solve it a little faster for some questions. So anyways, this is going to be, what's that, 27, I'm going to do this in my calculator, 27 times 4 times 2, 216 x cubed y plus 216 x squared y squared plus 96 xy cubed plus 16y to the 4. Okay, so you can see here, this is our expanded form of this, and we didn't need to do what would be really painful, which is to FOIL it 4 times over again, adding and subtracting like terms and all that stuff. We didn't have to do it all. Why? Because we used Pascal's triangle to solve it and the binomial theorem. All right, let's go ahead and try this one out. So this is kind of an interesting one because it's asking us to find the constant term. Constant term means that the term has no x, or like variable is really what it's looking for, no variable at all. And so here, how do we know when it's going to have no variable? Well, let's rewrite it a slightly different way. We're going to rewrite it like this, x to the negative 2. And by doing this, we can see that, hey, if this is exactly double this one, then they're going to completely cancel. So we want the positives and the negatives to cancel each other out. So what we know we need to have is 4x to the exponent something, and we want to have x to the negative 2 to the exponent something else in order for them to cancel. So if I do a 6 and a 3, it needs to add to this number 9. So I'll maybe call this a sum. It needs to add to the number 9, and it needs to cancel out that number 9, or cancel out the negatives and positives. So cancel out all the x's. So what we've done here is we've figured out that this is a certain term, and we also know that because this is to the exponent 9 up here, it's 9 choose something. Now it's 9 choose, so if we start counting down, this is how I would do it. So if this was a 9, exponent 9, it'd be 9 choose 0. If it was an 8, it'd be 9 choose 1. It'd be a 7, it'd be 9 choose 2. If it's a 6, it's 9 choose 3. So that's what I'm putting there. You could also do 9 choose 6, and it will actually work out just fine. But it's just how my brain works. So yeah, so anyways, that's how we get that value. And so now this is what the whole thing is going to expand into. So now we can actually type that out in our calculator. We're going to put in 9 choose 3, which is 84, and then times by 4 to the exponent 6. And so we get the answer of, this is a wildly big answer, 344 064. So this is our big expansion. This is our like constant term. And if we just look at the variables to double check, we could put x to the 6, x to the negative 6, and you can see that those guys cancel. So this is our final answer. Okay, so all of that is to be said that we don't need to expand out the entire thing. In fact, sometimes it's nicer if we don't, because we're able to solve these questions. Let's go ahead and try this next one out and see what that looks like. So if we expand this out and we want to have these two terms, well, what that tells us is that our final answer needs to be 2x squared to be able to get this x part. The y part needs to be negative y, 5y to the 3. And then we can go 5, choose 3, I guess. And again, you can follow the formula that's up here. And so, yeah, so if it was asking us to figure out the coefficient, we could go ahead and do that. So expanding all this out, let's use our calculator here. Oh, fun fact, if you press alpha, window, and then number 8, it gives you that perms statement, which is nice. Times 2 squared, whoops, times, I'm going to put negative 5 to the 3. And so we get negative 5,000 x squared y cubed as our final answer. So if you just plug it in the formula, it's actually not that bad. It's kind of scary, but it's not that bad. Let's try this last one. It says the 6th term of this binomial expansion. Well, we should really follow that formula. So what we're looking for is T6. Well, what that means is that it was 5 plus 1. If we look at that formula again, so let's just go back up here so we can see it. This is k plus 1. So keep that in mind when we do 9 choose 5 for our combination statement. Okay, and then for our x value, we can go 7x squared. And then to the exponent, what? Well, it's n minus k, so it's 9 minus 5, so it's 4. And then our y value, which is negative 3y. And then it's to the exponent k, which is 5. So we're just following that formula, and if you do, it works out pretty nicely because we can, again, plug it into our calculator. So alpha window 8, 9, choose 5 times, and then I'm just going to go 7 to the exponent 4 times negative 3 to the exponent 5. So this just gets us our coefficient. There you go, 73 million, blah, 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 and negative. But then to get our variables, a lot of people might say x to the 4, y to the 5, but what you've missed is that it's doubled here. So what we're doing is we're actually going to have x to the 8. And there's our final answer. Okay, so all that to be said, these questions can take some time and often mess people up, especially on the diploma. I recommend you really just take your time by expanding it yourself, or you practice a little bit ahead of time with the binomial theorem, and you can figure this out. Hope this video helped you better understand the binomial theorem using Pascal's triangle and combinations, and good luck.